Hello everyone, this is Goody K3NG. In this video I'm going to give you a tour of the various configuration files for the K3NG Arduino Rotator Controller. On the screen you see Microsoft Visual Studio Code. This is the program that I use to do code development. The concepts are the same within the Arduino IDE. The files will look the same. The user interface is just a little bit different with that program, but everything I say here will apply to the files within the Arduino IDE. First off, there is the K3NG Rotator Controller.ino file. At the beginning, you'll see lots of comments, and you'll see the revision history of the program over the last several years. And this goes from oldest to newest. And then the last update you'll see right here. And this shows you the code version. The code version scheme's very simple. It's year, month, day, and serial number. If I do multiple releases on a single day, you'll see that serial number increment. Down here is the code version. That should match that number up there. That's what's used on the various screens, the command line interface and whatever, to show you what version of software you're running. I'm not going to go down through the INO file in detail. That'll be in a future video. Today I'm just going to focus on configuration files. The first file that I'll mention very briefly here is rotator debug log activation.h. I'm not going to go into this file in detail here because I cover this in great detail in another video. So if you've come here looking for information on how to activate debugging, also how to look at debugging logs and interpret them, I suggest that you go for that video on the Radio Artisan YouTube channel. So the first file we'll talk about in configuration is rotator_hardware.h. We have in here a couple pre-built hardware profiles, and these tell you here which files are your features, pins, and settings files if you choose one of these custom hardware profiles. If you're not using any of these, the default files are applied at compile time. That's rotator features.h, rotator pins, and rotator settings. If you're going to use one of these hardware profiles, it's quite simple. Just uncomment that line, save the file, and recompile, and instead of these default files being used, like in this particular example here, you'll see these three files will be used at compile time, and those are the files that you want to customize. If you have all of these hardware profiles commented out, then the default files over here apply. So let's look at the next file, rotator features. This is the one that you're probably going to be spending the most time in doing customizations. This is really what sets up the personality for your K3NG Arduino Rotator Controller. You'll see in here various lines that you can uncomment to add features at compile time. Features like they would suggest, add features or functionality. We have language translations available. And you'll see down here options. Options may or may not add a little bit of code and make the compiled executable larger, but more often than not, it makes adjustments to the behavior of various features or the default behavior of the Arduino Rotator Controller. And we'll just look at some of the major features here and major options. If you have an azimuth and elevation system, you're going to want to uncomment feature elevation control. That changes the unit from an azimuth only system to azimuth and elevation. Yaesu emulation, that's the control protocol. That is the most popular one. It's supported in most every contest and logging program, so that's pretty much a no-brainer to go with Yaesu protocol emulation, the GS232 protocol. Not sure how many folks are using EasyCom or DCU1, but those are supported as well. Some secondary features here, we have moon tracking, sun tracking, built-in clock. You can integrate a GPS unit and have your time synchronized to that, and your latitude, longitude, real-time clocks to store the time when the unit's turned off, Ethernet, stepper motor support, We have, like I mentioned before, language translations here for the user interface. If you don't see your language listed and you're able to do a translation, would greatly appreciate it if you submitted a translation for your language or any language you're familiar with. These two sections here are where you set up the sensors for sensing azimuth, and if you're equipped for elevation, that as well. The most common sensors by far are potentiometer. If you're using one of the popular Yaesu rotators, they use potentiometers for sensing the position. If you're building a homebrew rotation unit, we support all kinds of other sensors here. I2C sensors, rotary encoders. It's really wonderful right now with all the sensors that you can get cheaply, magnetometers and accelerometers and all of that. And then the display, we support various LCD displays. This is the standard 4-bit interface, supports preset encoders. Right here, this one particular option is important. This is what switches between Yaesu GS232A and 232B emulation. Neither protocol is better than the other. They both do the same thing, although I have seen it with one particular logging program that had a bug working with GS232B, I believe, so you had to use GS232A. So don't hesitate using A or B. They're both equal in functionalities. It's just the syntax is a little bit different on a few commands. All of these features are described in much more detail in the wiki, so I really encourage you, if you're going to add features and you want to customize them and tweak them to your needs, please consult the wiki in GitHub. The next file we'll look at is rotator pins. This is what maps the hardware pins to various functionality in the code. You simply set the pin number here, and you'll have default pin numbers that are set based that are reflected in the schematics that you'll find in the wiki or elsewhere. But honestly, you can pretty much map the pins anywhere you like, although you need to keep in mind pins that are analog pins, like rotator analog as here. That has to be an analog pin. Hence, you see A0 here as the pin for that. If you put 0 for a pin, that disables the pin in the code. You'll see a lot of them set to 0 by default. Pins here for elevation control, and then we've got other pins for other options here, preset encoders, encoders for azimuth sensing. Here's where you set your LCD pins, and other devices in here that are supported. And then last, we're going to cover rotator settings. As the name would suggest, these are various settings, default settings, other settings in the code. Really important one here is azimuth starting point default, azimuth rotation capability default. When you initially start up the rotator controller, these values are written to EEPROM. If you don't set these correctly the first time and you want to change them in here, recompile and upload to the rotator controller, you're going to need to save the settings using the \Q command. That will write these settings to EEPROM. Otherwise, if you change them in here and recompile and EEPROM is already written, it will not update it in the code. There are ways within the command line interface to change the starting point and the rotation capability default, so you don't have to change them in here, recompile and run that /Q command. You can go directly in to the command line interface and update those at runtime. Here you have elevation, maximum degrees. Typically that's 90 or 180. various default calibrations for potentiometer. If you want to remap Yaesu speed voltages, the 4 steps that they have in there, you can do that here. Slow start, slow down defaults. As a new user with the rotator controller, you're probably not going to need to touch these. A lot of these go into detail. If you're doing like a homebrew unit, you may have to get in here. If you're doing like a rotary encoder and you need to tweak the behavior of that, how many degrees is 1 pulse from the rotary encoder, that sort of thing. If you're using an LCD display, there's various widgets that are set up with features and options over in the rotator features file. This sets up where things appear, like the GPS indicator here. This says it's on row 1, and on this particular setup it's all the way over to the right, so you can basically move things around using these settings. Real important setting up here is LCD columns and rows. So I hope this video has helped you out. As always, if you need help setting up your K3NG Arduino Rotator Controller, strongly encourage you to join the groups.io Radio Artisan group. Myself and lots of other folks on there would be happy to help you out.